Hello everybody, welcome back to another video. In this video, we're going to be taking a look at a question from the IB Chemistry Paper 2 HL from November 2020. Now, this question, they're asking us to calculate the Kb of the conjugate base of ethanoic acid using section 2 and 21 of the data booklet. So, all right, they've given us a good clue in the question itself to take a look at section 2 and section 21. Now, the equation that you're supposed to use in this question, and mind you, there is only one equation that you need to use. And if you use this equation correctly, you get your 1 mark and you get the correct answer. So the equation is Kw is equal to Kb times Ka. B for base and A for acid, well, obviously, right? So Kb is basically the dissociation constant of a base, and well, Ka is the dissociation constant of an acid. And we only calculate Kb and Ka for weak acids and weak bases. We don't calculate these for strong acids and strong bases, only for weak acids and weak bases. Now, why this is, I have explained in a previous video. I'm not going to get into it now because it is a long concept to explain. So please, if you do not know what Ka is, if you do not know what Kb is, you don't know what this dissociation constant is, please go and check out my previous video. If you search it up on my channel, you'll find it. And in there, I explain in detail what these terms mean. Now, this equation, or this specific equation, is only applicable. You can only use this equation for, for conjugate acid-base pairs. For conjugate acid-base pairs. Now, what do I mean by this? What is a conjugate acid-base pair? So let me show you what it is. Let me just erase this so I have some space, and then I'll show you what a conjugate acid-base pair is. And I'm going to use the example of ethanoic acid to show you what a conjugate acid-base pair is. Now, this equation is just something that I have come off the top of my head. It may or may not be a real equation, but this is just to show you what a conjugate acid-base pair is. Okay, so imagine you have ethanoic acid, like they have stated in the question, which is C3COOH, and it is reacting with water. So it forms H3O plus CH3COO minus. So basically, if you've understood what's happened here, you can see that H2O has took this hydrogen from ethanoic acid and it's become H3O. On the other hand, ethanoic acid has given away this hydrogen, as you can see, and it has become CH3COO minus. So that lack of hydrogen over there, the hydrogen that H2O robbed from ethanoic acid, now ethanoic acid is very sad. It's very negative. So it's become actually the ethanoate ion. So it's become CH3COO minus. But this reaction is actually also reversible. So it can also happen the other way. And in that case, because it's reversible, in that case, something else is also possible. In the reverse reaction, we have H3O. So the ethanoate ion, which is CH3COO minus, it steals one hydrogen from H3O plus, and it becomes ethanoic acid, and H3O becomes H2O. So that's also possible, right? It can go both ways because it's a reversible reaction. So if you notice what's happening over here, we can see that in the forward reaction, where the reaction is going this way, ethanoic acid acts as the acid, right? Obviously, because remember the definition of an acid, if you take a look at the Bronsted-Lowry definitions, the definition of an acid is a proton or a hydrogen donor. So the definition of an acid is an H plus, we call this a proton donor. And in the forward reaction, that's exactly what's happening. CH3COOH donates one of its hydrogen to H2O. And H2O acts as a Bronsted-Lowry base because the definition of a Bronsted-Lowry base is an H plus acceptor. So it accepts it. Oops, sorry. But that's only the case for the forward reaction. What about the reverse reaction? What about the reverse reaction? In the reverse reaction, now the tables have flipped, right? Because H3O acts as the H plus donor. It acts as the acid in this case. So this acts as the acid. And the ethanoate ion, or CH3COO minus, acts as the base because it accepts that hydrogen from H3O plus. And that's why the acid base pair in this can be defined as CH3COOH and CH3COO minus. These two guys, these two species, they are related to each other, but they differ by one hydrogen, right? Because this has this one hydrogen, this does not. So these guys are actually called a conjugate acid base pair. So this is a conjugate acid base pair. And similarly, you can also call H2O and H3O plus a conjugate acid base pair. It's the exact same thing. And this is applicable for many different things, right? You can even call NH4 plus and NH3 a conjugate acid base pair. And you notice that they're called a pair. A pair means that they're related to each other somehow. And you can see that all of these are related to each other in one or more way. And the main way they're related to each other is by really the stem of the element. So majority of the element is the same, but the only difference between these guys is that one hydrogen. That one hydrogen is the difference, right? Same case over here between NH4 plus and NH3. NH4 plus has one more hydrogen. NH3 does not have that one hydrogen. Again, CH3COOH or ethanoic acid has one extra hydrogen. However, the ethanoate ion does not have that one extra hydrogen. However, you cannot call HCl and NaOH a conjugate acid base pair. No, that is not true. Even though HCl is an acid and even though NaOH is a base, they're not a conjugate acid base pair because they're not related to each other. They're not brothers and sisters. They're not a family, right? They're nothing like each other. So even though individually this is an acid and this is a base, this is an acid, this is a base, but they're not a conjugate acid base pair. Whereas CH3COOH or ethanoic acid is an acid and CH3COO minus does act as a base, like how I showed you over here. It does act as a base and they're even related to each other. So you can think of them like brothers or sisters or brother and sister, right? And that's why they're called a conjugate acid base pair. Hopefully that makes sense to you. And just a quick fact, the conjugate base of a weak acid, so the conjugate base of a weak acid is very strong. So ethanoic acid, which is this, is a weak acid. That's why we calculate Ka for ethanoic acid. It's a weak acid. So the conjugate base of ethanoic acid, which is the ethanoate ion, this is the conjugate base of ethanoic acid. This is a very strong base. That's just a quick fact. And I've explained this in detail in another video as well. Now that we have settled the fact of what a conjugate acid base pair is, let's move on to solving the question. In the question, they've told us to calculate the Kb of the conjugate base of ethanoic acid using section 2 and section 21 of the data booklet. Now, I just showed you what the conjugate base of ethanoic acid is. This is the conjugate base of ethanoic acid. We know which equation we need to use. We need to use this equation. All we need to do now is refer to the data booklet and insert some numbers and we'll have our answer. So what is Kw? What is Kw? That's the first thing. Well, Kw is a standardized number and that's what you need to use section 2 for. In section 2, you will find the value of Kw. Kw is the ionic product constant for water or the dissociation constant for water. So like we have dissociation constant for acid and dissociation constant for bases, we also have a dissociation constant for water. So the dissociation constant for water is 1 times 10 to the power of negative 14 at 298 Kelvin. What about Ka? What is the Ka? What is the dissociation constant for ethanoic acid? And that's where you need to flip to section 21. Let's flip to section 21. In section 21, you can see strengths of organic acids and bases. Now, please make sure you have the most up-to-date data booklet. Otherwise, you might get a bit confused because the sections get shuffled around every so and then. So please make sure you have the most up-to-date version of the data booklet. Now, we found Kw, we need to find out what Ka is, because if we know what Ka and Kw is, we can easily find out what Kb is, right? Because we just have to then take this to the other side and we'll find out what Kb is. Now, what is Ka? Well, in order to find out Ka, like I said, flip to section 21, and in section 21, you will see on the very first page, under carboxylic acids, you'll see ethanoic acid, and it has a pKa. It has a pKa of 4.76. Now, how do you convert from pKa into Ka? It's very easy. How do you convert from pKa to Ka is like this. You just do 10 to the power of negative pKa. Be careful, you should put a negative. So it should be 10 to the power of negative 4.76. This will give us our answer as 1.738 times 10 to the negative 5. So this is the Ka of ethanoic acid. So you may be asking, why do we write pKa? What's the point of this? Well, really, it's actually something so trivial. The only reason we choose to write pKa is because the number is smaller and it makes it much easier for us to understand. That's literally it. That's literally it. Ka is a slightly more complicated number, right? 1.738 times 10 to the power of negative 5. That's a long number to say. So to make it easier for ourselves, we just convert it to pKa. That's it. And how do you convert from Ka to pKa, if you want to know? You basically do negative log of K. You'll need your calculator for this. So there's a function for log on your calculator. So just do negative log of Ka and you'll get the pKa. And the reverse from pKa to Ka, as I showed you now, is 10 to the power of negative pKa. Hopefully that makes sense. So now that I've calculated what the value of Ka is, let's just put it into our equation. So that'd be 1.738 times 10 to the negative 5 times Kb. Now all I need to do is isolate Kb and I'll find out what Kb is. So if I want to isolate Kb, I have to divide both sides by 1.738 times 10 to the negative 5. So these two cancel out. And over here we have 1.738 times 10 to the negative 5. Let me just erase this. And we get our answer as 5.75 times 10 to the power of negative 10. That is the answer to this question. That is it. That is how simple it is. That's all you have to do. Hopefully you've understood the concept. Thank you so much for watching this video. Please remember to show all your steps. I know it's only a 1-mark question, but it's always helpful to show your steps because it shows the examiner that you have an understanding of the concept. So please show your steps. Thank you for watching. If you have any questions regarding this concept or any other concept, please feel free to message me on my social media, send me an email, or put it in the comments below and I'll be more than happy to help you. Thanks all for watching. I'll see you in another video with another question and take care of yourselves.